Hi everyone. Today we're going to talk about sampling and external validity. Sampling is the process of choosing a number of people or individuals from a population in a way that the individuals are representative of the larger group or the population from which they were selected. A sample is any group of people, usually, in which information is obtained. Information is another way of referring to data. Population refers to all the members of a particular group. So the first task in sampling is to choose a sample to define the population of interest. So if you are interested in a group of people who possess certain characteristics or attitudes or behaviors, that becomes your population of interest. And the next task is trying to get a group of people, hopefully, who are representative of that larger population. Now, is it possible for the sample and population to be one and the same? Most people, when they visualize a sample, think of a subgroup of a larger group. And in some cases, the sample and the population are identical. Let's say that I were only interested in querying you, the 20 of you in this online class, about your attitudes towards the pending Cal State University faculty strike in April. If I were only interested in your attitudes about that and not generalizing beyond you, then the population and the sample would be one and the same. In other words, I couldn't extend findings of the survey that I sent to you to any other students. Now, some would say, well, what is the purpose of doing that? Why is that important? And many would argue that it probably is not a good idea. So it might be worthwhile for me to try to get a group of people that is representative of the students to whom I'd like to generalize the results of the study. In other words, the 30,000 students at San Francisco State. Another example would be the decennial census that the federal government employs every 10 years. Some political groups have argued that the federal government doesn't do enough to try to locate everyone to participate. But the idea is that the theory behind it is that the government is trying to collect information from the entire population, so there's no sampling involved. So the target population is the dream population. It's the population to whom the researcher would like to generalize. I'm doing this study on students in San Francisco Unified, and from this study I would like to generalize to all elementary school students in the United States. Usually that's not possible because the group or the population from whom the researcher accesses individuals for the sample is more the accessible population. Students in San Francisco Unified, for example, in elementary schools. So the more narrowly you define a population, the more narrowly or the more limited is generalizability. So that's sort of the cost of coming up with a sample, a realistic sample, because most people don't have the resources to be able to call a large random sample from a population. The textbook discusses two types of sampling, random or non-random. Random is a method of selecting subjects from a group or population to increase the chance or the likelihood that the sample is representative of the population. So random, as you know, means that each and every unit, person, has an equal and independent chance of being selected. And there are three common ways of getting random samples: simple random, stratified random, and cluster random. I wanted to show you very briefly an actual table of random numbers. That's an appendix in your textbook. And it's possible to actually construct or come up with a list of randomly selected individuals. If you were to have 100, for example, people on a list, you would number them 1 to 100. And using this table of random numbers, you could start at any column. Let's say you start at the upper left. You would choose the first 3 digits because there are 3 digits in 100 and select out the first, let's say 10. So the first number, 0, 1, 1, you would choose number 11. The next number is 912, which exceeds 100, so you would skip over that. The next number is 086, so you would choose number 86 on the list. The next number is 59, and you would choose number 59, and so on until you had 10 randomly selected names or numbers from that list. Again, you can do this manually, or you could use Excel or other types of quantitative spreadsheet software to cull a random sample. So as I mentioned, simple random involves selecting a sample from a population in a way that all members have an equal and independent chance of being selected. So some of the disadvantages are that it's very difficult and expensive because you have to identify each individual. Most times, random sampling does not necessarily ensure that subgroups are present in the same proportion that they are in the population. So these are possible disadvantages, and we've talked about some of the advantages. Stratified random involves selecting a sample where certain characteristics are represented in the same proportion in the sample as they are in the population. So the term strata refers to subgroups. Stratum would be singular. And the advantage is it increases the likelihood of representation, especially if the sample size is small. And it more or less ensures that any key characteristics of individuals in the population are included in the same proportions in the sample size. A disadvantage is that it requires more effort on the part of the researcher. So I'm going to let you look at the slides that show the images that are in the textbook, but I'm not going to talk through them. The next would be cluster random sampling, where it would be difficult to extricate individuals from an existing group, let's say school or hospital or airports, for example, and the sampling unit is a cluster. So the first matter would be to identify the groups or the clusters, and then using random sampling, choose individuals. So a major disadvantage is that a greater chance of selecting a sample that's not representative of the population can occur. Two-stage is where you initially choose clusters through random sampling, and then you go to the next stage of sampling individuals within those clusters. It's a lot less time-consuming, but it increases the likelihood of bias compared to individual sampling. So here are visual displays of simple, stratified, cluster, and two-stage. Now, most of you are not going to be using large random samples. Most of you are going to be using non-random samples. And there are basically three types of methods. The first is systematic, where you choose every nth, let's say 10th name in the population. And there are problems with that related to periodicity, which is a potential underlying pattern that could affect the outcome of the sampling process. Most of you will identify a convenient sample, not convenient, but convenience with CE at the end. And unfortunately, it sounds as if you're not doing much to collect the sample. But it is the most common because it's based on practicality. In other words, people that you have access to, you're more likely to get permission to participate. So even though you have a convenient sample, as I'm going to talk about in a few minutes, there are ways to try to maximize generalizability. A purposive sample is very common in qualitative research, where you have specific inclusion and exclusion criteria. In other words, you're not just using people that you have access to as in a convenient sample. You're actually considering certain qualities or characteristics or experiences that you want to be represented in the sample. So personal judgment is used for selection, and a potential disadvantage is that the researcher's judgment could create bias. All right, so again, illustrations of convenient sampling. So this slide shows non-random sampling methods. As I said, convenience is the most common. Purposive is also very common in qualitative, and if you have an opportunity to include exclusion or inclusion criteria or both, then I would say reframe your convenience as a purposive sample. And then systematic is also common. It's non-random, but again, there could be problems underlying systematic approaches to sampling. Now, most students are interested in numbers and sample size. So what is an adequate sample size? And I'm really using rough guidelines, but I want to give you the numbers because I'm basically operationalizing adequate sample sizes for this class. So if you're proposing to do a survey study, that's survey research, you should seek to have at least 100 people respond surveys to you. Now compare that to using a survey or questionnaire in a case study research design. In that case, you could have as few as, say, 10 people return the survey or questionnaire to you. A survey research method, as you know from having done the reading, means that you're collecting a lot of information, usually quantitative, from many people. So I'm operationally defining many people as at least 100. And those are people who have returned the survey to you. For a correlational study, you should have at least 50. And then an experimental or causal comparative study, you should have at least 30 in each group. Now, the purpose of this, because they're quantitative studies, is to try to detect statistical significance or effect size in the samples. And so having that number increases the chances that you're able to detect statistically significant differences. Some cases you can have as few as 15 subjects in each group, experimental or causal comparative, but that would be inconclusive and you would have to do replication studies. Now the other big idea that I want to talk about is external validity or generalizability. And external validity refers to the extent to which the results of a study can be generalized from a sample to a population. So there's population generalizability, the degree to which the sample represents the population, as well as ecological generalizability, refers to more the conditions or settings under which the generalization can be extended to. Now, when we talk about population generalizability in terms of convenience sampling, it's very limited. Most researchers would believe that if you're using people that you have easy access to, that they're more likely biased in some way. Now, I would say that if you provide a lot of information about the characteristics of your the people in your study, as well as sort of rich details about procedures and events in your study, that you could try to maximize the transferability of your findings. Now, I'm going to talk about what that means in just a second, but if you're using a convenience sample, there's no reason for you to not try to generalize. In other words, everyone, usually, most researchers want to generalize the results of their study beyond the group of people that they're studying. Most cases, researchers try to overstate their findings. So that's not what I'm suggesting. If you're doing a small-scale study using people that you have access to, you should not overstate your findings and say, now that I've done this study, I would like to generalize to a larger population. That is not possible, as you know, having done the readings. But there are ways that you can push for generalizability, which in qualitative research is called transferability. So in quantitative studies, if you have a large random sample, let's say, researchers try to generalize statistically from sample to the larger population, usually the accessible population. Qualitative research, that doesn't occur. In qualitative research, researchers spend a lot of time describing in very thick, rich, descriptive detail participants and events and procedures in the study. From that information, it's possible then that the reader or the consumer of the research, usually a practitioner, can then generalize on behalf of the researcher. If there's truth that the reader or consumer of the research finds, then the researcher or the reader can then use those truths or findings and perhaps use that to inform his or her own practice. So the transfer of the findings occurs from the reader. So theoretical generalizability is what transferability is about. In other words, the purpose of doing qualitative research is to try to produce theory. But if the researcher is unable to generalize, the reader or the consumer of the research may be able to generalize on the researcher's behalf. Okay? So again, statistical generalizability is where the researcher tries to make the generalization beyond the sample. That usually doesn't occur in qualitative studies. So replication of qualitative studies can be very important for extending out findings and trying to create a chain of evidence for qualitative findings. Now, this last slide includes 4 questions that I would like you to answer on the Sampling and Generalizable Discussion Board on iLearn.